Dr. Robin D Hanson believes advanced aliens are really out there, and we have enough data to say roughly where they are in space and time and when we'll see or meet them. Dr. Robin D Hanson, an associate professor of economics at George Mason University and a research associate at the Future of Humanity Institute of Oxford University, and I discuss his Grabby Aliens theory, along with his thoughts on the UAP experience on Earth and how his Grabby Aliens theory could possibly shed light on the UAP topic using a similar theory. Join us as we get rebelliously curious. Dr. Robin Hanson, thank you for being on Rebelliously Curious with me today. So you are the Associate Professor of Economics at George Mason University and a research associate at the Future of Humanity Institute of Oxford University. You are a busy man, that's for sure.
What shall we talk about?
Yeah, let's talk about Grabby Aliens, because
right.
That's something that for sure I know our listeners and our watchers love this type of topic, and we do at the debrief as well. So let's get into the paper that you did write with a group of other people as well. It wasn't just yourself, but there is this quote, and it starts off with the paper: "If loud aliens explain human earliness, quiet aliens are also rare." So before we get into that, can you explain what are Grabby Aliens? And then we'll get into what is then a loud versus quiet aliens.
So when we look out into the sky and look for aliens, there's roughly two kinds we could be looking for. Loud, that is really big and obvious, and quiet, i.e. hard to see. And we wanted to make that distinction because we want to analyze the loud ones because they're much easier to confront with data because they would be pretty obvious. And then in our paper, we defined Grabby aliens as a more specific mathematical model to capture this idea of loud aliens. We don't claim that it encompasses the entire concept, but it's a good approximation for thinking about it. So Grabby aliens are our version of loud. So Grabby aliens appear somewhere in space-time, and then they start to expand at some rate away from their origin, and then wherever they touch, they change. They make it different in some visible, pretty obvious way, which means that from a long distance away, they just keep expanding, and so they'll be taking up a really big volume somewhere, and it would just look different. They would have changed it somehow. And so if we could see loud aliens in our sky, we'd see these enormous spheres that were just different from the other places in the sky. That would be a big, really obvious thing. And then we can say, we don't see any of those, and try to figure out what that means.
Right. So there are parameters, though, and this is a mathematical equation if people don't know. So there are these parameters around Grabby aliens. Can you explain to us what those parameters are? Because I believe there's three kind of characteristics for these parameters.
Yeah. So it's a simple model that has three parameters. And the key thing is we're going to fit each of these parameters to data. So it's no longer speculation. It's a model fit to data. So the three parameters of this model are two parameters about when they appear in time, one parameter about how fast they expand away from their origin, and then a general assumption they appear at random places. So we're thinking of a relatively uniform universe, and at random places they appear, and then they appear in time according to a power law. That is, there's a constant and a power such that early on, they hardly ever appear, and then they slowly start to appear at a faster rate, and later on, they appear quite often. And there are these two parameters. Again, there's an overall constant and the power, and then the last parameter is just how fast they expand. So if they expand very slowly, then that just has different predictions for expanding very rapidly. And you might think this is all very speculative, but the key point is each of these parameters can be fit to data. So the power parameter, for example, comes from the history of life on Earth, which says that life had to go through a number of hard steps to get to where we are. And the chance of life appearing at our level before the deadline for life on Earth ended, which might plausibly happen in 1 billion years from now, that chance of appearing was a power law as a function of time. which is the power of the number of hard steps we had to go through to get to here. And so we can look at the history of life on Earth and see that there are two key periods, say the period before life appeared at all, the first appearance of life, and the period from now till when the window closes. And those two numbers give us a decent estimate of roughly how many steps there were, say 6. And so it's a power of 6. So that's one of the 3 parameters. And then we appeared at the moment at a certain date in the universe. It's now 14 billion years. And we can assume that we have a uniform rank from when these things appear. That is, we could have been early in the rank or later in the rank. We don't really know. So we assume a uniform distribution over what percentage of civilizations have appeared before us. And that gives us the constant in front of the power law. And the last parameter we need is the speed of expansion. And so we can run simulations of this simple model. And we can see that if the speed of expansion is slow, say 10% of the speed of light or less, then the prediction is at a random time when a civilization appears, if it looks up in the sky, it will see lots of other ones. Because the rate at which they're expanding is much less than the rate at which light gets to us from them. So we just see a lot. But we don't see anything. So that says the speed can't be that slow. And we find that if the speed is, say, a third of the speed of light or more, then we find that the prediction is you wouldn't see anything in the sky. They're expanding so fast, you won't see them till they're almost here. And that our conclusion is that must be the speed, because we look up and we don't see them. We would see them if they expand slow, so therefore they must not be expanding slow. They're expanding fast. And so now I've given you the 3 parameters and how each one of them is fit to data. And so now we have the answer.
So for anyone that's watching, what is a power law? And then I'd like to break down, these, I believe the values that you choose are N and L and these parameters within this mathematical equation that I will put up so people can see this. But, how, first of all, then, what is the power law? And then how do we and how did you even choose those values to fit in within this equation?
So if you have a ruler, the length of the ruler, is linear in, how long the ruler is. But if you have an area, say a square, the area of the square goes as the length, the side of the square to the power of 2. And if you have a cube, the volume of the cube goes as the width of the cube to the power of 3. That's a power of 2 and a power of 3. And you can have other powers up there. So a power law is just this dependence where you have some function as the input, like time, and then you raise it to a power, like square it, cube it, or some other higher number. And we say, therefore, the chance of life appearing at any one time in the universe goes as a power law of time that is, say, roughly time to the 6th. So that means when the time is twice as long, then it's 2 to the 6th, or 64 times more likely for life to appear at that twice time than at half time. So like right now we're at 14 billion years, and we might say, well, at 7 billion years, the chance of life appearing then was 1/64th the chance of appearing now. It's been increasing rapidly with time.
Right. So that makes us rare then, in a rare species. So, why are we rare? And is there a chance that we can evolve to be a Grabby civilization? Like, do we even know yet? Are we even at that ability to have that idea of what type of Grabby, if we're rare or we're not, or we're loud or we're quiet?
So this mathematical model is about the loud Grabby aliens, the one you could see from a long way off. And it says they appear roughly once per million galaxies. And then they grow with time as the 6th power, and they expand at almost the speed of light. And then the universe right now is filling up with them. And the idea is that at the moment we're quiet, and we might transition to becoming loud, and we might not. But if we do it, it'll be almost surely within the next 10 million years. And that might sound like a long time to you, but on the scale of 14 billion years, it's really not. So if we become loud, it'll be very soon cosmologically. And so that makes our date a good random sample from the dates at which they appear. So a key question in this model is, what is the ratio between quiet and loud alien civilizations? We are quiet now. We might later become loud. This ratio between quiet and loud, it could be 10 to 1, it could be 1,000 to 1, it could be 1,000,000 to 1, but it has two key implications. One is about our future.
Right.
If 1 in 10 quiet become loud, then we have a 10% chance of becoming loud. If 1 in 1,000,000 quiet become loud, then we have a 1 in 1,000,000 chance. So our future becomes much dimmer the higher this ratio gets. And it might be that we don't become loud because we all decide to just stay home and have a good time, but we might stay quiet because we die. So it's a little worrisome to have such a low chance of becoming loud. That's the one use of the parameter. The other use of the parameter is when trying to estimate how near is the nearest other quiet aliens. So I said, the loud ones appear roughly once per million galaxies. And if, say, the ratio was 1,000 to 1, well, that means that the quiet ones appear once per 1,000 galaxies. But that still means the nearest one is a long way away. So if you're looking out into space trying to look for alien civilization signatures, you're going to have to look a long way away to see that. And that's just the rate at which they appeared, but they may now have gone and be dead. For example, they may only last 1,000,000 years. And so a ratio of even 1,000 to 1 is pretty bad news for SETI, the search for extraterrestrial intelligence, in the sense that you're going to have to look a long way off and maybe just be looking for ruins because they're not anywhere nearby. If the more you were hoping to see them nearby, then the higher ratio you need between the quiet and the loud, so that there might be someone nearby, at least the ruins of, to notice. So I myself would rather we have a promising future than that we see some ruins nearby, but I don't get to control this. But that's this key parameter that we don't know. What's our future chances?
Right. And so I have so many questions. So before we get into that part, though, can we just, for the viewer and the listener, break down what hard steps mean within this equation and what they are in context of, say, our development right now, human development?
Right. So we're the only example of advanced life in the universe that we know of. We're the only example of any life in the universe. So we have to rely a lot on our one example, but we can still figure out a lot from it. So first, we have to see the universe seems to have started out just dead, like nothing. And so the very first step has to be just some initial kind of life, some very simple kind of reproduction that can get the whole game going. And then that simple kind of reproduction can go through natural selection to evolve to be more efficient and more effective. And then there are many steps to go through between very simple life and what we are now. Life had to, say, find photosynthesis. It had to evolve what are called eukaryotes, which is a more complicated internal structure. It had to develop sexual selection, where the cells exchange genes and reproducing. And then multicellularity, where we have larger organisms like you or I, made of many cells. And then even with us, we had eventually had to have bigger brains and culture and technology. And so we've seen this history of all the things that happened in our ancestors to come to where we are. And the idea is that this getting to where we are must be pretty rare. Otherwise, the universe should have been full of life for a long time, but it looks really empty. So the really only way to understand the universe being empty is that it must be pretty hard to get to where we are, and especially pretty hard to get to where we hope to get soon. So if it's really hard, that means this process that moved from the no life to where we are must have what I've called a great filter. It must just have a lot of ways that you could fail along the way, or that it just takes a really long time along the way. And we've gotten lucky in making it down this whole path before the deadline of our planet no longer supporting life and other alien civilizations taking over the universe. So it must have been hard. And the question is, well, which of those steps were how hard? And it turns out what the main thing that matters is just which of the steps were very hard. So you could break all the steps that came to us into steps that were pretty easy, such that it just took a little bit of time to get to the next thing, and steps that were just really hard in terms of the universe just had to keep trying and varying different combinations, and it was over and all in some big chemical soup, bouncing things around until it finally found the thing that worked. And so we have a simple model of what would happen if there were just a whole bunch of these hard steps, each of which would take a very long time, but then you found one of them that was lucky, and that's the simple hard steps model. Now, this model is actually the same model that roughly describes cancer in you. So you are made of trillions of cells, and each of these cells undergoes mutations that have a very low rate, and you get cancer if some cell in your body gets 6 mutations. And each of those mutations is so unlikely that most cells in your body have no mutations. And then a few of them have 2, and an even smaller number have 3. But eventually, before the end of your life, you have roughly a 40% chance that one of your cells will become cancerous. But that will happen toward the end of your life. There's the power law. The same power law says that the time at which you get cancer is much larger toward the end of your life than the beginning, because you have to have time for a cell to accumulate all 6 of those mutations. And that's the same model that's applying to planets in the universe, just like cells in your body. So each planet slowly is trying to go down the path. Most planets never even get to the first step. Most of those never get to the second one. Only a very tiny fraction ever get through 6 steps, say, to where we are. And that's why we're so rare. And we can actually use the timing of these events to roughly guess that there are 6 steps. As I said, we have the time of how long did it take till the very first life seems to have appeared. And we have the time from right now until the window closes. And the simple theory says those are each drawn from the same distribution of how long a step should take. All the hard steps should take roughly the same amount of time, drawn from the same distribution. And that's how we can figure out how many steps there were. So we don't actually know which are the hard steps, but we can still guess how many.
So great. I love, and like listening to you break that down is so lovely, because I find it to be very relevant. Now we know that you have to travel to be a Grabby civilization. It says that you have to travel at least at the speed of light or advance of the speed of light. So now here is the question. So that's why we're not seeing other Grabby aliens, because they're moving fast and they're ever expanding. Now I'm going to get into a question of this in the UAP topic. And I know everyone watching this who likes UFOs will be happy I'm saying this. But when we look at probes, right, we have humans that are making probes right now, and we're looking at sending them out, or, from satellites to different crafts, and we're observing the universe now, right? Now, if we look and we're sending probes even more into interstellar travel, and they're traveling at the speed of light, is it possible that we would run into a Grabby civilization? Sorry, if it's traveling lower, just below the speed of light, would we still run into them? Is that something that would be even possible? Or do we literally always consistently have to travel at the speed of light so that we won't be able to? I know at one point we will meet them, or our spheres will intercollide. But what if we're traveling just below? Does that mean that we are not rare, but we might still be able to meet another civilization?
So at the moment, our technology makes our maximum speed far, far less than the speed of light.
100%.
Now, maybe that'll change in the next century or millennia, but at the moment, when we send out probes, they are going very slow.
Right.
And we are not sending very many of them, and they're not going very far. So the chance they would meet Grabby aliens are extremely low, according to the simplest model here, because again, they appear roughly once per million galaxies. And so the nearest one is just a long way away. Now, they are very advanced. And so again, our data suggests that they must be expanding at a substantial fraction of the speed of light, say maybe a third or more. But I'm still accepting the simple physics that they can't go faster than the speed of light, and they must therefore be going slower. But it's less about how fast any one probe is going, and more the idea that they have a whole sphere they're occupying, and the border of that sphere is moving at a big fraction of the speed of light. That is, they are very rapidly moving out and just taking everything within their scope and using it somehow. And then it's less about noticing one little probe and more about noticing an entire sphere of activity that's, millions of light years across, coming toward us, and coming here rapidly. So if it expands very rapidly, we won't see it until it's nearly here. But then when we do see it, it'll be this huge sphere in the sky, much larger than the full moon, and expanding very rapidly. And that's what we would see as we were being approached by a Grabby alien civilization. And of course, they might see us that way if we had become one at that point too. So there's very little chance you wouldn't notice them. Again, they're occupying a large fraction of the sky, and they've changed it enormously, and that sphere is expanding toward you. This isn't like a little thing you might miss slipping past you. This is the universe changing.
Right. So then we get into things like Avi Loeb, who's discovered in, a Mu, for example, that potentially we don't know what it is, but he's saying it's an alien artifact, or looking even at the UFO conversation right now. How does that even play a factor? Because then the concept of Grabby alien theory and the method does not exist within if UFOs are real. If we're saying that if the government telling us that they are real, but in context, if they are extraterrestrial, let's say, or not anything else interdimensional, then how does this all play? Like, did you think of those elements when building out this theory? And I know that it's not, let's say, uncommon science to be like, hey, I'm going to think about UAPs in this, but looking at, Avi Loeb's conversation with Harvard and Oumuamua, if that is an alien artifact, then that means that is coming into our own sphere, and that would have came from another sphere at somewhere else, and potentially could have been a Grabby alien.
So the universe is a vast and complicated place, but as always, almost in academic or scientific reasoning, we start with simple models and we see how far we can get with them, and then if they're missing something, we add some more complexity and see how far we can get with that. But we're usually trying to be sparing, especially if you don't have much data, because if you have a complicated model with more parameters than you have data, you're just hard to know which model is right. So we're starting this with the simple 3-parameter model, each of which we can fit to data. But this simple 3-parameter model is pretty confidently saying the nearest aliens are a really long way away. Now, if you tell me, yeah, but we seem to see something, what if those were aliens? Are you sure that they couldn't be aliens? And I'd say, this model says they aren't, but that doesn't mean I'm sure. I might say, okay, let's see if I can find a variation on this model that can accommodate that. So then the next step would be to say, what would be the most plausible variation on this model, such that its prediction might be that there would be some aliens nearby that look and act something like UAPs. And I've tried to do that exercise. I tried to say, okay, how can we vary this model? And there is, I think, a relatively straightforward way to do that. So the simplest Grabby Aliens model says aliens appear independently at separate places in space. And the average distance between them is really far, again, once per million galaxies. But a variation on the model is to have them cluster in their appearance, to appear in little clusters together. And a way to do that is with panspermia. So the standard story of life on Earth would be that Earth was dead and then life appeared on Earth. But a variation is to say, well, there was another planet before Earth, billions of years before Earth, and life appeared on that planet. And then it went through billions of years of evolution, and then some rock smashed into that planet, kicked off a rock from that planet with life inside, that drifted elsewhere and seeded another place. And it plausibly could have seeded the nursery where Earth was formed. So most stars are formed in nurseries, groups of 1,000 stars, say, all forming at the same place and time, very close together. And in that nursery, rocks are flying all around really fast. And so if a rock had come in there and seeded that whole nursery, it might plausibly have seeded many, many stars in that nursery all at the same time, and many planets around them. And then Earth could have gotten its life from there, but then many other planets might have too. And these 1,000 stars that were all born in the same time and place then relatively quickly drifted apart. And by now they'd be in a ring around the galaxy, spread out at different places. And we can actually identify them in the sky. That is, they have exactly the same spectra as our sun because they had exactly the same mix of chemicals in that nursery. And so we can actually find them in the sky. And we have found some of them, other stars from our nursery. So the idea would be these other stars had planets that also started down the path of life. And this was the huge correlation where even in a million galaxies, this hardly ever happens. But here, a bunch of places all right near each other, all started life together. And then the simple hypothesis would be, they each went through all these different steps, trying to get through the hard steps to reach an advanced level. And then at least one of them got there before us. And now it would be, only a few thousand light years away. And it would have appeared, say, roughly 100 million years ago. That is, the statistics of this sort of process, they wouldn't appear in the last 1,000 years or even the last million. That would be an amazing coincidence. Most likely they would appear tens of millions of years ago at least. So under the scenario, one other planet in our galaxy achieved our level of advanced civilization 100 million years ago. Wow. And they could have come here as UAPs. That would be the scenario. So I don't think that's terribly unlikely in the sense that panspermia isn't terribly unlikely compared to the usual assumptions. So I don't think you're making a really strong assumption there to assume panspermia. So that makes that scenario somewhat plausible. But I think you'll have to add other elements to the scenario in order to construct a whole scenario that actually makes sense of UAPs as aliens. That is, there's a number of other things that we have to explain. Not just the idea of aliens being here, but there's several other elements of the scenario we need to make sense of.
Yeah, right. Because we get into conversation about interdimensional and there's lots of other things. How would you, and we've talked about how we would change the scenario now. Have you looked at changing the formula in something that would be advanced, maybe including that, maybe not? Is that something that you've thought about doing with your other research associates?
The formula doesn't need to change, really.
Okay.
But we have several other things we need to explain. So we need to elaborate the scenario to explain the other unusual features of it. So one feature is,
right,
if aliens are here right now, they are not everywhere else in the galaxy right now. That is, they have not changed the galaxy. So we need to somehow explain how it is that they appeared 100 million years ago. They could have easily filled the galaxy and changed it all in that time, but they didn't. But nevertheless, they are here right now. So that's somewhat puzzling. That is, you might have expected them to just go everywhere, in which case you would have seen enormous changes around us, or you might have expected them to go nowhere, in which case they wouldn't be here. But instead you have they are not most everywhere, but they are here. So that's a thing we need to explain. And I think we can come up with some hypothesis to explain it, but the question of how life. And then another thing we have to explain is that if they are here right now, they are sitting in some intermediate level of visibility. So if they're 100 million years more advanced than us, they could easily have been completely hidden. They could watch everything they wanted without ever giving themselves away. That would be completely feasible for someone that more advanced, or they could have been completely visible. They could have just made themselves really obvious. And so apparently, if UAPs are aliens, they did not choose either of those extreme scenarios. They chose this intermediate scenario of hanging out near the edge of our visibility, being visible, but not letting very much detail about themselves be revealed. That's also a thing that needs to be explained. So the whole story here is, if we want to explain UAPs as aliens, we have to construct a scenario that explains the major elements that would be needed to make sense of that. And the question is always going to be, how strange or unlikely are the assumptions we need to make such a scenario? So the more unlikely these assumptions are we need to make this scenario, the more we're basically saying that's pretty crazy unlikely. You're having to make up a really weird scenario to make sense of this, which means it's just harder to believe, right? On the other hand, if you can make up a scenario without really stretching it very far, the elements are pretty plausible, then you might say, well, this scenario isn't crazy. It might be wrong, but it's not crazy. So we need to really look at these things carefully to find out what the truth is.
Right. And there's so many conversations around the concept of like, what is it, and we're looking, I believe that if they travel faster than the speed of light, we're looking at playing with the context of space and time. I don't know if I'm correct with that. Would it be possible that they are traveling, that any form of these Grabby aliens are traveling quicker than the speed of light? And that could be through a use of a probe, though, too.
Right.
Yeah.
We are at a particular place in space-time.
Right.
And in principle, aliens could have originated anywhere in the universe in space-time, right? Now,
right.
if you can move faster than the speed of light, then it turns out that means you could get to here from anywhere in space-time. Right. That makes the puzzle of why no one's here all the more dramatic. You see, if the speed of light's a limit, you see, then you can say, well, only things in our backward light cone could have gotten here by now. And then there's the puzzle, why is that empty? But in all of space-time doesn't need to be empty when the speed of light is a limit. That is, the future could be full of advanced things who just can't get back to here. But if you assume you can go faster than the speed of light, then anybody anywhere in space-time could get to here right now, which makes the lack of any of them being visible all the more dramatic. I find it just very hard to explain how it is that we see very little around here right now, consistent with the idea that anybody in space-time could have gotten here. Because wherever you start in space-time, you could then fill up all of space-time by traveling away from there. Right. So that's why I would think, it's just if time travel is possible, or if faster than light travel is possible, then the only assumption I could come to is then we're the only ones. It's all completely empty except for us. That's the simplest way to make sense of that, because anybody anywhere could be getting here.
That's a good point. And why wouldn't they be? And well, I don't know.
You have to make up some explanation.
Place. Right,
so
exactly.
that's why,
there's so many assumptions.
I tend to stick with the speed of light being a hard limit on travel. That at least I can work with that to come up with some more plausible scenarios.
Right. And when in case we're looking at warp technology right now, there's tons of conversations from NASA, all these independent organizations like Limitless Space that are working on warp technology. Have you been following those conversations? And then have they even reached out to you to talk about this plausible theory as well of Grabby aliens?
Again, the details of how you might be able to travel faster than light don't that much matter for the idea that if you could get anywhere in space-time. So I think we are still not sure whether these technologies work. But again, if they would work, then the only way I can see to make sense of what we see is that we have to be just completely, utterly alone, because we would then be the origin of everything that moves everywhere in space-time. And so I have a physics background, and I got to say, my guess is it's just not possible. You just can't travel faster than the speed of light. That would be my guess about these things. But that also fits with the idea that we aren't crazy alone. There could be other things very far away that we just haven't been able to get information about yet.
Yeah, background to the UAP topic, and you can answer this or not. This is up to you. What do you personally think then might be going on when you're looking at this theory and you're hearing all this conversation right now from the New York Times? We've had a preliminary assessment report that came out last year. We're looking at having another report that hasn't been released yet. That's late, and we're having all these conversations from the New York Times to Politico to you name it that are talking about UAPs within government, entertainment, news. What's your thoughts around that? And then also, developing something like this as a theory, because it does lean into it a lot.
So stepping back and just trying to do a careful analysis, the way to think about it is that there are, say, 4 major categories of explanation. And in order to figure out what we call a posterior, a degree of belief in each of these categories of explanation, you should start with what's called a prior, an initial set of expectations, and then a likelihood, i.e., based on a particular set of data that we see. So the basic overall project of evaluating these things is to construct a prior probability for each of these hypotheses, and then ask for each of those hypotheses, how likely would the data we see be according to that hypothesis? And then you multiply those two things to get a posterior and renormalize, and that's what tells you what to believe. So the observations are related to the likelihood, and you have to look at the details of these observations in order to judge the likelihood of each observation according to each of these theories. And that's not my area of expertise. So I can just make some rough comments of saying, look, we have seen things that seem similarly crazy turn out to be true. And if I look, say, for the best evidence I could find for ghosts or fairies, it looks to me a lot worse than the best evidence for UFOs. So that just says somebody needs to look at this carefully. But that's not me, because I'm not an expert in the likelihood, but I am more of an expert in the prior. That is, I am an expert, a world-class expert, if I say so myself, in constructing scenarios that could make sense of each of these categories of explanation, and then judging their relative prior probability. That is, just ignoring the observations, how plausible is it that something like that would be true? And in particular, I've tried to work out a prior for the UAPs as alien scenario,
Right.
but also think about the prior for the other three explanations. So, for example, they could be just mistakes and delusions.
Right.
That's another category of explanation. They could be some other hidden Earth organization with amazing capabilities, or it could be hoaxes and lies where somebody is really trying to fool us to make us think amazing things are happening when they're not. Those are four categories of explanation that need to be considered in order to judge which of them is true. And so we've been talking about here about the aliens hypothesis and constructing a prior for that. And so my guess is that a prior for that is roughly 1 in 1,000, which is substantially higher than most murder trials, which say it might be 1 in a million. So, any 1 in 1,000 people get murdered, and roughly they have 1,000 associates nearby who might have done it. So if you accuse any one person of murdering any one other person, well, our prior probability on that is 1 in a million. But we allow murder trials because evidence in trial is often quite capable of overcoming a 1 in a million prior to convince you that in fact it happened. Here, if it's a 1 in 1,000 prior, well, it's even more likely, so you really should look at the evidence. And so that's my job, is to try to come up with the best scenario I can to make sense of it and ask how likely that is. Although I have to admit, the hoaxes and lies scenario, I got to give more like a 1 in 100 prior to. That is, people have lied and made hoaxes about things like this in the past, and they've gotten away with hiding them for a long time in the past. So it's also not crazy that someone could be making all this stuff up and lying and faking evidence in order to convince us of something. That's another scenario I think you have to take seriously.
Now, you're saying 1 in 100 with that scenario, but 1 in 1,000 with the UAP scenario, or I believe like aliens, right? Of alien scenario. So why? Like we've seen, I think there's been more data collected around UAPs, and not I'm not going to go straight for extraterrestrial, but just UAPs in general, right? There's more data collected, and there's been more incidences, millions, hundreds of millions, from around the world consistently, daily. Doesn't mean that all of them are UAP related, or some, we don't know what they are, but wouldn't that bring down the percentage then to closer to 1 to 100? Because we know a lot of people lie, but we've only had so many cases around this topic that people have lied, from the American government and people making up things. But I would think that there would be potentially more data with people and collected, because we don't know how many people are lying consistently, but more data collected showing that there is evidence of UAPs and potentially extraterrestrial life or other things.
So when I talked about these four hypotheses, there are hypotheses to explain UAPs. That is, we're focused on UAPs and we're asking, how can we explain those? And of course, we're trying to explain the whole set of all the observations, not just one of them. And really the question is there any of them that are explained by, say, aliens? That is, almost surely many of these observations are, in fact, mistakes and delusions. That's quite possible. The question is there a subset of them that has to be explained some other way? And then, definitely some things have actually been hoaxes and lies. We know that. Well, the question is there something left after that That is, are there actually craft out there with amazing abilities, either from hidden Earth organizations or from alien organizations? That's really the interesting question. And that's what we're trying to evaluate here, is how much to believe in that. And so that's what we're thinking about when we're asking about these priors. What's the chance that some of them really are aliens? Or what's the chance that the things that look like aliens really are some sort of systematic hoax? And that's what we're trying to judge the prior of, and then the likelihood.
Right. And this method that you have and this theory, if it's not right now, it's not fully mainstream, like it hasn't gone mainstream. If it ends up at some point being baked into the mainstream, how would this change science, and how would this change, culture around us and how we view our world around us today, but then also what will be potentially for us in the future?
So, as you may know, among, say, conservative or traditional standard prestigious academics, the usual response has just been to dismiss it and just to assume it's obviously hoax and delusions. That's been the overwhelming response so far. And I got to say, that'll probably continue for a long time. That is, there's been a burst of some attention by, say, the US government lately, but that doesn't look like it's big enough to me to overwhelm the inertia and, distrust of academics worldwide. So I got to say, the status quo will continue for at least a while. But, we will continue to have more evidence accumulate, and it's possible that that evidence will continue to move us away from our initial skepticism toward believing more in these things. And then the question will be, what do we conclude about that? So again, the two major hypotheses in my mind are the hoax and the aliens story. And so then the question is, which of those will accumulate more evidence? And depending on which one of those that is, then people would have to start to come to terms with that. So we could walk down either of those paths, if you like, and ask more specifically, what does the most plausible hypothesis there look like? And what would that imply if we took it seriously?
Right. And
which one would you like to go? Which one would you like to start with?
I'll let you choose.
Well, let's start with the hoax and delusions, because that had the highest prior probability. So, it could be most plausibly, say, some part of the US government has had a program for many decades to convince the world that there are things that look like aliens around. One plausible reason they could have done that is, in the Cold War, your enemy might attack you, and they might think at some point they have some secret, clever way to attack you that will resist your retaliation for them. And the idea might be to make them a little uncertain about whether there's not a third party who would be offended. So if you're just trying to prevent your enemies from attacking you, then it just helps to add some uncertainty in their mind about whether there are only these two parties or whether somebody else might take offense and get involved, right? And this could then serve that purpose, just to create an uncertainty in, say, the Russians or the Chinese mind, that if they thought they had a super, reliable way to attack us without us responding back, what if there are these aliens around and they might not like it? And how sure are you want to go with that, right? So that would be a plausible reason why they might do that, get in their heads, and they have plenty of budget to do this. And then the question is just, are the sorts of reports we've seen the sort they could have faked? And of course, like, if the major reports are from the US military, well, yeah, they could do that. US government could get the US military to lie about things. That's quite feasible.
Yes.
But so that would be the question. But I think if we came to believe that the US military had been doing this long hoax for a long time, then I think we have to believe they could have lied about other stuff too. So, for example, the moon landings. They faked the UFOs, maybe they would have faked the moon landings. We would start to reconsider a range of other things that similar sources have claimed that maybe we'll have to start re-examining and doubting again. That would be where you would go if you started to become more confident that the UFOs the UAPs were basically the results of an organized hoax.
Right. And well, that's a huge cultural, obviously, if we're evaluating everything we've ever been told, then if we're looking at that, then that would change everything that we've obviously been told and believed through any form of government, right? I'd like you to go
Or
to your
any sort of authority that's been supported by government or that has a similar
100%.
sort of power. We would just start to doubt a lot of things we've been told, and maybe that would be healthy. Maybe we've been too gullible.
Yeah, I'd so many things there, Robin. It's true. And now your second part of what you were saying, of breaking this down. I love to hear that.
So the other scenario is like, so I think we should have to go back to asking what's the most plausible scenario that could make sense of UFOs being aliens. That's the thing we would end up believing in, and that would then change how we all think about things. But we need to ask, what is that scenario? So again, I said the first element of that scenario was that they were panspermia siblings who arrived in the same galaxy near us, but 100 million years ago, roughly. And they then came to visit us here. So I think the next thing we need to add to the scenario to just make sense of they're here now, but they are nowhere else we can see, is the idea that they chose to prevent their civilization from colonizing the galaxy and the universe. They had some policy where they decided we like ourselves better when we are integrated all together in one place where we can regulate and rule each other and communicate closely. And if we allow any part of us to go out and colonize the universe, then that's the end of that era. Then these things, we have competition again. These different parts of us will evolve to become strange alien things. They can come back and contest with us here again. And we don't like that. So we're just going to not allow that. And that would explain why they didn't colonize the galaxy and the universe in those last 100 million years, why, it seems all empty. Now, if they had this rule against expanding, the first thing we can say is they successfully enforced that rule for 100 million years. So they have the capacity to do that. That's an impressive capacity. And they didn't die in 100 million years. So they have an impressive capacity to persist and enforce this rule. So you got to raise your respect for them in seeing that they could do this. And now you have a plausible reason why they would make an exception to come here. They would know that if we, became very capable, we might expand out and break their rule. And if we break the rule, that's the same as them breaking the rule from the point of view of the consequences for them. So they might want to be here to prevent us from breaking their rule. And that's why they might plausibly make an exception for one expedition very far from home, even though they clearly don't allow very many such things, because that's the only way they could have made this rule work over 100 million years. So we've made this one more assumption. They have this rule against expansion that they are here to enforce. That's why they came here and haven't gone anywhere else. And now we've explained more of the scenario. That is why they're here, but nowhere else we can see. We still haven't explained that last part of the scenario. We still have yes, but why are they in an intermediate level of visibility? They are not completely invisible and they're not completely obvious. So to explain that last part, I'd say, well, how are they going to convince us? So we know one thing they could have done is just destroyed us. That would be completely in their abilities. And they could have done that for a long time. They didn't. So we can conclude they have some degree of empathy or attachment to us, and they'd rather we voluntarily follow their rule rather than them destroying us or simply forcing us to follow their rule. So the question is, how are they going to get us to voluntarily follow their rule? Now, the way that humans have domesticated other animals is the way that humans have domesticated themselves, which is through status hierarchies. That is the way a human domesticates horses or cows, is to present ourselves as the highest status versions of them. We are the top dog or the top horse. And if we show ourselves to be especially impressive and capable and powerful and close and not too hostile, then they accept us as the leader of their pack. And then they do what we say. And that's how we have domesticated other animals and ourselves. That is what an emperor does in a history, was to have an impressive castle and crown and army and palace, and to basically say, I am the most powerful and impressive person around, and you should follow me. So and in fact, most social animals have status hierarchies. That's a very robust feature of social animal life on Earth. And so we could postulate that's also true for the aliens, that they, in their world, saw status hierarchies, and that the way to domesticate things was by being the most impressive versions of things. And so they've decided to come here and try that trick with us. They're going to domesticate us, at least to convince us that they're the top dog here and that we should defer and follow them by doing what we've always done, i.e., being very impressive, being close, not being hostile, but just being very consistently very impressive. Now, so doing what they're doing does achieve that, but it doesn't fully explain, well, they needed to be somewhat visible as opposed to invisible to make this happen, but why not make themselves completely visible?
Right.
Well, the answer there might be, they probably have seen in their history, as we have seen in ours, that even very similar humans often learn to hate each other when they learn some slight detail of the other ones that doesn't fit with their culture. And so they are really our aliens. So they really are much more at risk that we would hate them if we just learn some various random details about them, because we are just very unforgiving about random details about other humans on Earth today. So they realize that if they show us a lot of detail about them, the risk is, it turns out they eat babies. They think that's fine. We find that entirely repulsive. And so we won't be domesticated by them because we find out they eat babies. So
a level of mystery is
they just can't show very much about themselves. So what they need to do is just make it really clear they're there and that they're peaceful and that they're very capable, and that will be enough for us to accept them as leaders, as the better creatures around. And that would be enough to get us to do what they want, because we're smart enough to figure out why they're here and what they want. They don't even need to say anything, right? We're right now, we're figuring it out. We're saying, okay, they must have had this rule against expansion. That's why they're here. Here they are showing they're here. That must be what they want. There are already large parts of our culture that already are not very comfortable with the idea of humans going out and expanding in the civilization, that we already think that might be too aggressive or harsh, and that maybe we should leave things alone and be more peaceful about such things, or less expansionary. There are many people who don't even like the idea that our descendants might go out and compete with each other militarily or evolve into strange descendants that are no longer very human. There's already many people who find those to be relatively repulsive scenarios, and they would be embracing this alien message of saying, yes, follow those instincts. You don't want to go out and expand. You don't want to allow your descendants to become strange aliens. You want to stay here and limit your expansion. And that's what they're here to tell you. And they are superior, 100 million years more advanced, far more capable. And this is their one message. And many people would be quite inclined to listen.
Okay, there's so much to unbox too. So if we're looking at breaking these down and these aliens, are they Grabby then still? Because I just want to make sure I'm following the narrative properly.
No, so these would be non-Grabby aliens.
They would be non-Grabby aliens, exactly. So they
chose to be non-Grabby,
right?
But they're our siblings, and they want us to be non-Grabby.
Right. But then there would still be Grabby aliens, right, obviously, and we would at some point obviously come to a demise.
So they would know that their plans are going to fail in another billion years anyway.
Interesting.
That is, in another billion years, real Grabby aliens will come, and they just won't be able to resist them. They won't be able to stop them. But for the next billion years, they might be able to maintain this peaceful galaxy that they like,
in hopes that we don't become Grabby, because we could at some point transfer, or we haven't made we haven't found out if we've made that decision yet to be Grabby or not. So I guess that means Grabby means invasive then, right?
Expansionary and changing things. Yes. So that's the key idea of Grabby. You expand out fast and you change the things you touch. You don't leave them the way they were. You take them apart, rearrange them. You are not leaving things in an
Right. So at some point, then we're looking at these spheres that are moving then consistently with all of these Grabby aliens. You're going to get a point then where there are no Grabby aliens, I would imagine, at all, because it's the Grabby aliens have taken up all of it.
What you mean is there would be a point at which all the volume of the universe was filled with Grabby aliens. There was no volume left for anyone else.
Right.
Right now, it could be that some Grabby aliens will allow quiet ones to just sit in a little pocket for example, they might, go past them and surround them, but let them stay in some little pocket just to observe them. For example, it'll just only be a tiny fraction of the volume.
Now, could that be us now? Could that possibly be us now?
That could only be us now if right now the universe around us has been filled with Grabby aliens, but then we would expect to see something changed.
But we wouldn't see them then if they're Grabby.
Well, we should. No, but if they're Grabby, they should have changed things. That is, they should have taken apart the stars, rearranged them, make enormous machines of various sorts.
Okay, interesting.
Have super highways. They would have just made things different. Just like we've always made things different when we go, develop an area. And though life has made things different on Earth whenever life has invaded somewhere and prospered there.
Yeah, now, also, this is going to be an interesting one. The concept of infinity, right? Because we look at infinity being vast. So there is every single explanation possible with infinity. You want a world of this, you've got it. It's probably going to happen because infinity never ends. Have you looked at that when doing your own method and your own calculations around this, or even within this method, that putting affinity into that, or what it would mean if we're all evolving and expanding? Because then what does that mean for Grabby Aliens? Because can't everybody play a part in that then too?
So most mathematical models in physics and elsewhere are finite models.
Right.
And sometimes people also consider infinite models, but it's actually pretty hard to consider infinite ones because usually there are multiple dimensions on which you could make something infinite. And then you get different answers depending on in what direction you make things infinite first. So that's a problem in decision theory and even in cosmology. And so I've always tried to stay with finite models as long as I could. And in this area, I can't. That is, here we can focus on a finite volume in the universe, say the observable universe for a finite time, and look in a finite time into the future. And we can figure out lots of things from that in a robust way. And so I don't need to look at infinity. And because it's hard to look at infinity, I will set it aside here. So this is a perhaps, general analysis heuristic. That is, when you're focused on any one thing and trying to understand it, then when you have some other dimensions of the analysis, some of the dimensions might be fun assumptions you can introduce. They might be provocative and thought-provoking, but usually you want to make the simpler, easier assumptions in any one thing to figure it out and understand it. So most of the world, when we design cars and houses and everything else, we mostly design it using things we understand that are relatively robust, that we expect we know how to predict what they'll do. We make girders in houses and steel in cars, etc. There are other things in the world that are hard to predict and weird and interesting, but we don't tend to use them to design things because that makes the things we design unpredictable and hard to rely on. So that's also true in modeling and analysis. Whenever you analyze anything, your first attempt is to try the simplest, most obvious, straightforward things you can. And if you can figure it out in those terms, you're usually happy to do so and avoid things you don't understand. So, that's why I'd say here, I don't need infinity. I won't use it. And I'm happy with that because this is my focus.
What inspired you to then start to write this paper and go down this whole rabbit hole?
Well, over 20 years ago, roughly 25 years ago, I was reading in many areas and just came across this topic, and it just seemed to me obviously important. And so I started to think about what I then called the great filter, i.e. what the obstacles between life and now are. And I did a bit of analysis and was kind of surprised that I could come up with a novel way to think about it that other people hadn't already done, because it seemed to me just so obviously a big, important topic. But then it wasn't in my area of expertise. I was trying to, become a successful economist, and my colleagues said, this isn't economics and you should not waste too much time with it. And so I set it aside and had it more on the periphery for a long time. But then a few years ago, I happened to read a paper where I noticed that people had neglected this power law I talked about. And this power law had big implications. And so that's what tempted me back in. I said, well, people haven't thought enough about the power law in the context of the great filter. And so I should do that analysis. And I realized it had some substantial implications that people hadn't talked about. And so I realized that even though I'm not an astrophysicist and there are other people out there supposedly who specialize in this, maybe I am the one who should work on this, because I'm more willing to do a wide range of things. I am I've continued to be surprised about how many big, interesting topics are just neglected by the academic world, because we often just clump. Basically, we tend to want to form a clump of people all working on the same thing so we can all say that thing's important and judge each other's work. And so between the clumps, we just leave many interesting topics untouched, because anybody who goes and tries to work between the clumps is all alone, with no allies and supports and nobody to say they're doing good stuff. And then some of these topics, like the origin of life, people have the sense that it's too hard and you just couldn't do anything on that. That's also true for futurism. And so for some of these topics, I've just ignored the sense that it must be too hard to make progress and just tried anyway. Turns out if you just keep trying anyway on things people say are too hard, often you can succeed.
Yeah, and you actually brought up a lot of interesting points where we look at the stigma around the science community, but then we also look at people being like, oh, this is too hard. Are there cultural identifiers that you've looked at that might say, yep, we're not Grabby? Are there any of those kind of landmark or catalyst moments where we would be able to say, not just based on technology and us going off planet, but for example, like having narrow-mindedness and thinking that, well, this is too large, this is too big, I can't go there. And also I'm going to ridicule my peers around, looking into something that might not be always mainstream. Are those cultural identifiers of potentially not being Grabby aliens?
So we know to a substantial extent what we are like, but then we're trying to guess the distribution of other alien civilizations on various parameters, and that's really hard. Now, some parameters just have a limit in terms of there's a number, it can only be in a certain range. So for example, how many genders do aliens have? Well, we can say we have 2 genders, roughly, and you really can't have much fewer than 2. So maybe some of the ones will have more than 2. So maybe that's a way to guess that on average they have more than 2, because you know what? You can't have less really than 2. or you can only have 1, right? So I think the best way to sort of judge how we compare to some sort of aliens would be to have some sort of way to put a boundary on what's possible and notice that we're at the boundary. If we are at some extreme of what's possible, then maybe they're off in the other direction. But there aren't very many of those. So it's actually pretty hard to guess. Like if we say, are they more aggressive or less than aggressive than us? I go, could be either way. I'm not so sure. Is their technology growing faster or slower than ours? Could be either way. I don't know. There's just a lot of ways in which we could go in either direction from where we are and still perhaps be a plausible alien civilization, at which point it's just hard to say. Now, I think one thing we can be pretty confident of is by the time we became substantially Grabby, our descendants will be artificial. That is, they won't be, old style biology anymore. They will be made in factories, designed explicitly. And that's just what probably most aliens are. So that's a way we can reason about what most Grabby aliens are going to be like, based on what we will become in the future. But that doesn't say so much about where they started before. So if you want to say, yeah, these Grabby aliens in the future that we meet, they're going to be artificial, but what were they like before they were artificial? Well, that's going to be much harder to judge.
Do you think that we will become Grabby, just in your personal opinion? Not because I know that's something that we won't know, and it's all speculative, but do you feel that in the future we're actually, very lucky in that 1%, or we will evolve to be?
I honestly have to say that when I've done surveys or asked people about this ratio parameter, it's usually well above 2. So I can't reasonably make it less than 2, in which case I got to say the odds are that we won't. I think I'd rather we did, but odds are no.
The way we're going, we don't seem like
the odds seem like they're against it, but I hope that's wrong.
Well, let's hope. I know they say in 8 years we do have to turn it around, especially with the climate crisis and everything else. And I hate to leave that on such a sad note. But thank you so much, Robin. Such an amazing conversation, and I've learned so much. And I know I'll be leaving here thinking about Grabby Aliens consistently. I was talking to my dad about it last night too, and I think I've sent your paper to multiple people now to have conversations with. So thank you so much. And as I say to all of my guests, thank you for being rebelliously curious with me today.
It was great to be here.